Can you talk about some applications that you've specifically, or at least your company has specifically worked on? And like, so, say, oh yeah, there was this case, or there is this particular treatment, or there is this new breakthrough, or there is this, can you kind of give us a for instance of how your work has been applied?
I can't talk about our specific partners that we're working with that would actually bring these treatments to the clinic. So a lot of that's still kind of proprietary and
Okay.
who we're working with. But I've actually had to learn a lot about these kind of different cancers and stuff. And my background's in biochemistry, but not cancer biology. And so really in the last year or so, I've had to learn a lot. And it was somewhat serendipitous because my father was actually diagnosed with cancer just over a year ago too. Right, I had already applied for this position and knew I was looking to work in this, this company, but I hadn't got the job yet. So I found out my father was diagnosed, and then I got this job, and so I've been studying these different types of cancer. My father was diagnosed with multiple myeloma, and that's actually one of the cancers that's being treated with CAR T cells, and it's actually very effective for multiple myeloma. And multiple myeloma it's a cancer of the blood cells.
Wow.
And
That's
it's
circular.
yeah,
Like now we're back to
yeah.
the
Now
blood
we're back
cells.
to
Yeah.
the blood cells, and these cancers have been historically very hard to treat because there's no solid tumor that you can go and cut out. It's kind of all throughout your bone marrow and your blood. And so having a therapy like CAR T cells that can just go into your body and hunt for the cancer everywhere has been very effective. And most people wouldn't say cure, but it's been very effective in putting it into long-term remission at least. So, looking to the future, that might be something my father's eligible for, and it gives me a lot of motivation to work on the project too, because it's something that's close to home, and I can feel like
So
I know what the end goal is, what I'm actually working for. It's not just
Wow. You must be
selling
their
it.
best employee.
Well, I don't know about that, but at least I have some
Yeah.
deeper cause to work for.
I would say so. But trials have shown promise.
Yeah, yeah, yeah.
Gosh, so then it's just a matter of waiting, I suppose.
Waiting, and the cost is still an issue. This cost and whether insurance covers it. So right now, if you can get into these clinical trials where it's covered by the company that's developing it, it's kind of it's more risky because it's still in a trial, but it's nice that you don't have to worry about figuring out how to get
Yeah.
paid for. And
Yeah, heck, you get paid to do it.
yeah,
Maybe. I don't know if they do it for cancer
they'll do it for
patients.
free anyway. I don't know if
Yeah.
you get paid because
This isn't like they have those.
you're not a healthy volunteer that's getting paid. Yeah,
Right. Well, I mean, I don't mean, if you don't want to get too personal with this, we don't have to. But are you like looking into like where these trials are taking place, and
Yep,
and since
yeah.
you're in the industry, that this is a lot of promise. Sign up for this trial. I mean, do you have that kind of insight or insider information or whatever?
Yeah, so I definitely. I mean, I don't know about insider information, but I know about I look at some of the treatments and I can assess like, yeah, this one looks really good. You should try this. And
Can you? Does he have a say over what he tries? Can he tell his doctor, hey, I want to do this?
he has some input, but the way the insurance companies have it set up is, they have first line treatments, second line, and you have to kind of go through in order.
Okay.
And part of it's that first line treatments have been around longer. They're better understood.
Yeah.
But they're also cheaper. So they want you to try, chemotherapy drugs because they've been around a long time, and they're more effective than they were 20 years ago, but they're not as effective as some of these newer therapies. So,
Wow, I'd say.
yeah.
I mean, this is a whole other. It's like chemotherapy. You're like injecting, or you're introducing some kind of foreign agent to kill the cancer, obviously,
Yeah.
and that's the goal. But then you end up doing a lot of other damage
Yeah.
along the way.
So instead of teaching the T cells to target a single enemy,
Yeah.
you're firebombing the whole landscape. And,
Scorched earth.
Yep. Yeah.
Let's stick with war.
Yeah.
Right. I don't know. You're not a sniper here. You're just bombing the whole
Yep.
carpet bombing it. Yeah.
And a lot of those are pretty brutal. Just the drugs themselves and the side effects.
Has your dad had to do any of that?
Yeah, so he's gone through a couple rounds of chemo, and he had a bone marrow transplant this last summer, which sounded like it was hell on earth. Just they use your own bone marrow, but they use high dose chemotherapy to kill all of your bone marrow in your body, and it's not very fun to go through. And he had to be in isolation because it erases your immune system. And erases all the chemotherapy erases all your fast growing cells, so your intestines and all your mucous membranes slough off, and it's pretty horrible. Lost all his hair, and but it was
Oh my
yeah.
God. That's the scorched earth.
Yeah, it is.
The earth grows back, but my God, what a...
But it grows back from kind of scratch. He had to get all his childhood vaccines over again because he erased his immune system.
It's like a reset.
Yeah, it's a reset, and hopefully, without cancer or with less cancer,
Okay.
So it's hell to go through, but it's fairly effective. It's not as targeted as these new ones. So he's now in remission. So hopefully that lasts for a while. But hopefully there's some good CAR T therapies on the market, if and more likely when the cancer comes back in a number of hopefully years. But
and that particular kind of cancer is one that your technology might very well be used to address. But you're not able to talk about like the specifics you said of the drug companies or the companies, the medical companies that you're working with, you said?
Yeah, that's right.
Yeah, okay. But can you talk about the application? Like, we're working, you can't say who you're working with, but we're working to, I don't know, we're taking something to trial and clinical trial, and we're hoping to have a new method of addressing your father's kind of cancer by the year 2025. I mean, do you have that kind of roadmap?
I mean, kind of. A lot of it is dependent on the companies that are actually developing this. So that actually develop the cars, and we're a tool for them, is kind of the way they see it, and we're hopefully a better way to put their therapy into action better than the virus. And so we're hoping that some of these will be brought at least into trials within the next year or something. Would be great if that happens.
And are the virus?
So we don't know though. It's up to the companies.
Are the virus-induced T-cell re-engineers kind of there to like compete with you guys then?
They are, and they were first movers, so people in the market are more familiar with them.
Yeah.
But there's a few things that we can do that they can't, and so especially these bigger ones, or if you want to put two cars in, you can't put them both in a virus.
Yeah, you can't double up. You got to choose,
because the physical size of the virus is you can only put so much DNA in there, otherwise it just doesn't fit.
What if they tried both? Like, well, we'll do viral and we'll do I'm sorry, say it again.
Transposon.
Yeah. Can you do that?
You could. They'll sometimes try two different viruses with the two different cars, and it just your efficiency of getting them into the cells just goes way down when you do that. So,
gosh, I suppose your company has salespeople, right? And they go and they try to talk to these. I guess drug companies, but this isn't going to be a drug. This won't be a pill.
It's not a pill.
It's a therapy.
But it's still classified by the FDA as a drug. So
the same drug companies, Merck or whoever, might be the ones to...
Some of these are focused more on these kind of biological or gene therapies specifically. But it's going to be some of these big drug companies that are well known.
Okay.
And biologic drugs, which includes cell therapies and stuff like this, but also antibody drugs, have really taken over the market, especially in terms of sales. So of the top 10 grossing drugs right now, I think most of them, maybe 7 of them, something like that, are all biologics. They're not these little small molecules like aspirin or something like that.
Yeah.
They're antibodies, or they're cells, or there's some living or complex molecule or living cell. So
is this sort of a new wave of medicine over the last 20 years? It's been more toward these biological therapies.
Yeah, because it can be very specific and very targeted, and especially patient specific. Because a lot of these, especially the CAR T cells, you'll find this marker that the CAR T cell will recognize, but each patient is different. So you might say, a protein called BCMA is one that they target a lot on multiple myeloma, but not everybody has that on there. So you can test each patient to see, does your multiple myeloma, does it have this target? Is that should we use these snipers, or should we go get these mortar guys over here, this other T cells?
I've been hearing about how the fact that we can sequence our genome can also specify medicine. Is that related to this too?
Yeah, because you can actually sequence the cancer genome specifically, not even just the patient's regular genome, but this mutated genome that's in the cancer cells. I have a graphic that shows the cost of sequencing. This is really kind of mind-blowing how much this has changed in the last 20 years. So the Human Genome Project, it was completed in, I think, 2001, and it cost about $3 billion. Yep, this is the one.
There you go.
Yeah, so in 2001, the first human genome was done. It says 100 million here, but if you count the whole project, it was actually $3 billion to get that first genome sequence. you might have heard of Moore's law in computing. The speed doubles or the price halves every 18 months.
Mm-hmm.
And that's what this blue line on this chart is showing is
Oh, so
Moore's
it's
law.
way
So this
faster
is
than that.
faster than Moore's law. And so now you can do a whole genome for about $1,000. So it's
What are those kits that you can do for 23andMe?
so they're still not doing the whole genome.
I
They're-
guess not.
They're
They're
looking
talking
at
about $100
Yeah,
or-
so they're looking at specific nucleotides or specific parts of the genome that they're known are either associated with health conditions or are correlated with certain ancestries. But it's getting to the point now where you can do testing and sequence the whole genome, and it actually creates lots and lots of data that researchers have to dig through. And so
Too much noise?
there's a lot of noise, but you have to figure out how to pull out that signal. And a lot of my work actually has been moving into kind of bioinformatics. So I'm at the computer about half the time writing Python code to analyze sequencing data.
Wow.
And, these companies, I send them DNA, and they'll send me a hard drive with all this sequencing on it, and I have to go through gigs of data and process it and analyze it.
I guess that'll be for another conversation.
Yeah,
Like now getting into that aspect, I never even imagined you'd have to do that for your work. I pictured you in a lab with a lab coat, which you are, but
Yeah, I'm probably about half and half at the computer and at the bench.
wow. And writing computer code.
Yeah.
Was that in the job description?
No, it wasn't. Especially before we got acquired, and we still kind of have this small startup mentality, our group, but we kind of fill in which roles need to be done. And so somebody asked me, hey, can you look at this sequencing data we got? I don't know how to analyze it. Can you figure it out? And so I spent some time. Let's
Wow.
and a lot of it's new, and some of it has easy to do stuff, but
What's the flame for in that shot?
so some of our techniques has not changed since the 50s. So
Okay,
the flame just is a way to keep things clean. You can either, if you have metal utensils, you can flame them to sterilize them, or it just
Okay.
kind of keeps the air semi-sterile.
Oh, okay.
So I'm growing bacteria here on these petri dishes. If you're working with human cells that are a lot more susceptible to contamination, you'll be in a biosafety cabinet, which keeps everything completely sterile. But when you're working with bacteria, they're pretty robust, so I just do it out in the open air, but I have a flame nearby to keep things a little cleaner.
We didn't touch on your work with bacteria, did we?
The bacteria are just making the DNA for me.